Hello, future engineers, subscribers, viewers, and students. So here is the continuation of Algebra 8. I hope that you will enjoy listening, watching this video. So let's now have a discussion on vectors. So a vector may be represented by any one of the following ways. But let's have the first way as our popular way of representing a vector because it is the common way. So boldface, then we have AXI plus AYJ plus AZK, where AX, AY, and AZ are the X, Y, and Z scalar components of the vector, and I, J, K are unit vectors in the direction of X, Y, and Z respectively. So you should present represent a vector in this manner because the second one is confusing because of the similarities in describing a point with coordinates, but the only difference is the first letter representing the vector is boldface, so it is still boldface or with arrowhead, then the scalar components inside the parentheses. But I suggest let's have the first one. Then we have the magnitude of vector A is simply square root of the sum of the squares of the components. So square root of ax squared plus ay squared plus az squared, and that's the absolute value because it's the magnitude of vector A. Then we have vector operations. The first one is the dot product. We call this scalar product because the results of the product is scalar. And it is vector A dotted with another vector B, and the result is A times B, magnitude of A times magnitude of B, times the cosine of the angle between them. So we call that product scalar product. A dot B is magnitude of A, magnitude of B, cosine of theta. Then A dot B, we will expand that later after I expand the product of unit vectors. So I hope that the application for that product is clear here. For instance, A cosine theta, this is the component of vector A in the direction of B. And B cosine theta is the component of vector B in the direction of A. And the angle theta is the angle between the two vectors. So we can find the angle between two vectors by this dot product here. And we can also find the component of one vector in the direction of the other and vice versa by using this dot product. So let's have the unit vectors. I dot I. So by this definition, magnitude of I is 1, magnitude of I is another 1, and the angle between I and I is 0, which is cosine of 0, and cosine of 0 is 1. Therefore, I dot I times 0 is 1 times 1 times. I dot I is 1 times 1, cosine of 0, which is 1 times 1 times 1, so it is 1. So again, magnitude of I is 1, magnitude of the other I is 1, the angle between I and I is 0 degree or 0 radians, cosine of 0 is 1, so that's why it is 1. J dot J is also 1, K dot K is also 1. However, dotting I with another vector is 0 because the angle between them is 90 and cosine of 90 is 0 degrees. So that is I dot J is J dot I, it is 0. So it is commutative also. That product is commutative, so it is 0. I dot K is K dot I, it is 0. J dot K is equal to K dot J, 0. That's it for that product. So therefore, if we have vector A in this form, vector B in another form, we just replace this by bx, by, and bz. Since I dot j j dot k0 and the commutative, we now have an idea that a dot b is simply ax bx, I dot I is 1, so ax bx plus ay by plus az bz. So I want you to explore it by yourselves, that dotting a with b. So you multiply this, or you obtain the dot product of another vector bxi plus byj plus bzk, and take note that I dot j, j dot I0, I dot k, k dot I0, k dot j, j dot k0. So only I dot I, j dot j, and k dot k would be 1. So meaning when you obtain the product by expansion, then we get axi times bxi. So ax bx, I dot I is 1. The rest would be 0. So ax bx plus ay by plus az bz, that would be a dot b. Then for the applications, as I said, these are the two vectors. One is we can find the angle between the two vectors, because it is simply after expanding this as ax bx a plus ay by plus az bz divided by the magnitudes a and b, then we can compute theta. So for the other application, we just drop a line from the tip of A perpendicular to B, and therefore this is the projection of A in the direction of B, and that is a scalar A cosine of theta. So A sub B is A cosine theta, and A cosine theta is from here. It is A dot B divided by B. So A sub B, the scalar projection of A onto B, or the component of A in the direction of B, that's the other term, is equal to A dot B divided by B. A dot B divided by magnitude of B. So you don't need to memorize, you just draw two vectors, then from there you can imagine and think of this component A sub B as magnitude of A cosine of theta, and find that from this formula here for that product as A cosine theta. Therefore it is A dot B divided by B. The scalar projection of A onto B, or the component of A in the direction of B. Then for the other component, we draw a line perpendicular to A from the tip of B as shown. So this is the component of B in the direction of B, B sub A. And that is B, the hypotenuse, magnitude of B cosine of theta. So B sub A, which is B cosine theta, is equal to A dot B divided by A from here. So A dot B over A. And that's the scalar projection of B onto A, or the component of B in the direction of A. So that's for that product. Now, if you want to express these scalar values into vectors, A sub B, for example, if you want this to be transformed into vector form, all we have to do is multiply this, because this is a scalar, by the unit vector of B. And the unit vector of B is U sub B with arrowhead, or lambda of B, and that is simply vector B divided by the magnitude of B. So A sub B in vector form is equal to this scalar value, A dot B over B. Then we dot that further by the unit vector of B. So as a result, because unit vector of B is vector B divided by its magnitude B, it becomes A dot B close dot B, another dot dotted with vector B all over B squared. Actually, you don't need to memorize that. Once this scalar value is obtained, all you have to do is dot it with the unit vector of B. Once this scalar value b sub a is obtained, this, dot it with the unit vector of a, which is vector a divided by magnitude of a. So that's the vector projection of a onto b. And let's have the vector projection of b onto a, which is b sub a. Let's make it vector. All you have to do is dot this with the unit vector of a, and it becomes a dot b close dot a all over a squared. You don't need to memorize again. All you have to do is concentrate on this component. From this, of course, you have to know the dot product. You memorize that. Then this is b sub a, magnitude of b, cosine of theta, and you can find that from here. It is a dot b divided by a without looking at that formula. Then if you want this to be in vector form, this scalar value should be dotted with the unit vector of a, which is simply vector a divided by magnitude of a. And it becomes a vector. So the vector projection of b onto a. The unit vectors are defined as, so u sub b, which is lambda of, u sub a, which is lambda of a, which is vector a divided by magnitude of a. And u sub b, unit vector lambda b, is equal to vector b divided by magnitude of b. So that's it. So another vector operation is the vector cross product. So the result is vector. It is simply another vector perpendicular to the planes of the two vectors a and b. So if you have a cross b, it is defined as magnitude of a, magnitude of b times sine of the angle between them. But this results, this one is another vector which is perpendicular to the planes of a and b. So to illustrate that, let's have these unit vectors first. And let's define the cross product I cross j, for example. So all you have to do is position your four fingers towards the I direction here, the four fingers, your four fingers. Then curl it towards the j direction and look, observe your right thumb. Your right thumb is pointing towards the k direction. So again, I curl towards that direction. Your four fingers, four fingers, curl that in that direction. Your right thumb will be pointing the k-axis. So I cross j is 1 times 1 sine of angle between I and j, which is 90 degrees, and it is equal to 1. And because your right thumb is pointing the k direction times k, that's direction, so it is equal to k. While I cross I is equal to 1 times 1 sine of angle between I and I is 0, so it is 0. J cross j is also 0. K cross k is also 0. While I cross j, as I said, is 1 times 1 sine of 90 degrees. And because your right thumb is pointing towards the k direction, the unit vector k, so it is unit vector k. So I cross j, this is 1 times 1 sine 90 degrees. It is equal to 1. And because your right thumb, as I said, is pointing that direction, the k direction, positive k direction, so it is equal to k. While if your four fingers begin here, in that direction, curl it towards the I direction in the opposite way, then you will notice, so it is counterclockwise positive, so it's k. Clockwise, your right thumb would be in that direction, in the negative k direction. Therefore, j cross I is negative k. Then, your four fingers now would be directed towards the j and curl them towards the k in, that's why we have counterclockwise direction again. You will notice that your right thumb will be pointing the I direction. So therefore, j cross k equals I. So that's the guide. While it's not commutative because if you begin with K, curl your forefingers towards the J, it is pointing towards the negative I direction. So you can verify that with your hands now. Forefingers from the J, then curl them towards the I. Your right thumb will be pointing towards the negative I direction. So K cross J is negative I. And finally, K, four fingers towards the K direction, curl them towards the I direction. Your right thumb is pointing the J direction. So K cross I is equal to J, while I cross K is equal to negative J. I, four fingers towards the I, curl them towards the K. Your right thumb is pointing the negative J direction. So that's why I cross K is negative J. Then what's the geometric interpretation? So this is vector A, vector B. Now, position your four fingers towards the A direction, then curl them towards the B direction. As you curl them towards the B direction, notice that your right thumb, which is perpendicular to the planes of A and B, will be pointing that direction. And that is A cross B. So that's the angle between them. You curl your four fingers here, curl them towards the B direction. Your right thumb would be in that direction. So this is A cross B. And by principle, A cross B is another vector perpendicular to the planes of A and B. Perpendicular, perpendicular. And that's A cross B. Now, these sides would also be the sides of a parallelogram. And from trigonometry, the area of the triangle joining the tips and the tail here is 1/2 base times height. This is the height. The base is A, magnitude of A. The height is this. From the tip of B perpendicular to this. And this height is simply magnitude of B times sine of theta. Therefore, which is A times B sine theta. A, then B sine theta, 1/2 A times B sine theta, which is the height. There is only 1/2 here. Therefore, this is interpreted, if we double this, as the area of this parallelogram. Because half, which is this triangle here, the area is 1/2 product of adjacent sides times sine of included angle. So from trigonometry, the area of a triangle is 1/2 the product of adjacent sides times sine of included angle. Why is it so? Because the original area is 1/2 base times height. If you make A as the base, the height is from the tip of B perpendicular to A, that's the height, then you can form a right triangle with right angle here, and the angle is theta. Then that height is opposite to the projection of B. So magnitude of B sine theta is the height. Therefore, the area of this triangle, 1/2 A B sine theta, 1/2 AB sine theta. If you multiply that by 2, therefore AB sine theta, which is the magnitude of A cross B, the magnitude of this vector, is geometrically interpreted as the area of this parallelogram. So the area of the triangle defined by vectors A and B is 1/2 AB sine theta, where B sine theta is the height. Therefore, doubling that area is the area of the parallelogram. And therefore, the magnitude of A cross B, which is AB sine theta now, 1/2 of AB sine theta times 2. 1/2 AB sine theta is this half area of the triangle, times 2, it becomes the area of this parallelogram form. So the magnitude of this vector perpendicular to A and B is the area of the parallelogram. Likewise, if you position your four fingers towards B and curl them towards A, then A cross B would be the opposite direction in this downward direction here. So that's why the right thumb rule is important in defining the cross product. So area of parallelogram is absolute value of A cross B, because this A cross B may be positive or negative. As a result, the positive value of that is area of parallelogram. So I hope that you can remember that. Then the last applications or operations is this scalar tripole product. If you can recall from statics, this is used in finding the moment of a force about an inclined axis. Finding the moment of a force about an inclined axis. So uh, for those who have already gone through with statics, you can understand what I'm talking about. But for those who are still yet in their early years in engineering, you haven't yet uh, enrolled in statics, so just wait until you reach that statics. For the meantime, in this part, let's have the other applications, which is interpreted as the volume of the rhomboid. So again, we have A, we had B, then A cross B would be that. So the angle is theta, then A cross B is this vector here, perpendicular to A and B. And the magnitude of A and A cross B is the area of this parallelogram. Then if we have another vector, which is the edge of a rhomboid, so that's the area of parallelogram, absolute value of A cross B. So this is the edge of the rhomboid. And if we project its height or length along A cross B, it is now the height of the rhomboid. So this is now a line perpendicular to A cross B, so that the distance from the tail to that perpendicular foot is equal to the height h, and that is magnitude of c cosine of this angle here, which I'll call beta. And that is obtained if we have to obtain A cross B, then we dot that with vector c. And by definition of that product, it is magnitude of A cross B times magnitude of C times cosine of the angle between them, which is cosine of beta. So, and the magnitude of A cross B is area of parallelogram. So, volume of rhomboid is equal to area of the parallelogram, area of the base, times height h. And if we perform the operation A cross B, that vector C, the expansion from that product would be magnitude of the first vector, because this is a vector, A cross B is a vector from here, times magnitude of C times the angle between these two vectors, A cross B and C, which is beta in this case. And since we have cosine of beta here, we interpret C cosine beta, magnitude of C times cosine of beta, as the height of this rhomboid. Therefore, area of the base, area of parallelogram, this is the height, is the volume of volume of rhomboid. Area of parallelogram, absolute value of A cross B, magnitude of A cross B, times H, which is C cosine beta, is the volume of rhomboid. So that's it for this video. I hope that you get the idea, especially on the applications of that product, cross product, and this time scalar tripole product. So before we leave, let's have this example on vectors so that we can recall all this. So for the system of concurrent forces shown below, determine, letter A, the magnitude of the resultant force, the angle that the resultant makes with the y-axis, and the angle formed between R and F2, the resultant and F2. So these are the vectors, forces, F1, F2, and F3. And we have to obtain the resultant as the sum of these forces. So F1 plus F2 plus F3 is 3. We simply add corresponding components. 3i plus 7i minus 6j is 10 minus 6, 4i. So take that 4i. Then 6j minus 4j is 2j plus 14j is 16j. So 4i plus 16j. Then negative 10k plus 3k, negative 7k minus 8k is negative 15k. Therefore, the resultant is 4i plus 16j minus 15k. So R is 4i plus 16j minus 15k. The magnitude of this resultant is square root of 4 squared plus 16 squared plus 15 squared. You don't need to have quantity negative 15 squared because it is still positive 15 squared. So the magnitude of the resultant is 22.29 units newtons. Then for B, the angle that the resultant makes with the y-axis. So if you perform that product between R and Ry, the result is magnitude of R, magnitude of Ry times cosine of theta y. And since R dot Ry is, because we have R and Fy rather, F R and Y. So the unit vector is J. So R dot J, remember, we can only obtain the product, that product of J and J. The rest will be 0. So it should be Ry J dot J. Ry dot J dot J is Ry because J dot J is 1. So Ry divided by Ry divided by R because the unit vector of J is 1. So R dot J is R, magnitude of R times 1 cosine of theta y. So cosine theta y therefore is equal to Ry over R. So cosine of theta y is Ry over R. You can also show that cosine theta x is Rx over R. Cosine theta z is Rz over R. So substituting, cosine theta y is Ry 16 over R 22.29 inverse cosine. So theta y is equal to 44.13 degrees. And finally, the angle formed between the resultant and F2, since this is the resultant in vector form, and we can find the angle between them by getting the dot product between R and F2. If you obtain the dot product of R and F2, remember, it is just the corresponding product of components. So 4 times 7, I dot I, so 1, so 28, 16 times negative 4, negative 64, and negative 15 times 3 is negative 45. Negative 64, negative 45, negative 109, plus 28, and I think that's negative 81. So R dot F2 is negative 81. Magnitude of R is this, 22.29, but if you want to make it exact, we can evaluate that. Magnitude of F2 is square root of 7 square plus 4 square plus 3 square. So cosine theta R2 is R dot F2 over magnitude of R, magnitude of F2. That is R dot F2 is R times F2 cosine of the angle between the resultant and F2. So R is square root of 497. This is the decimal equivalent. You just evaluate this without extracting the square root. So you just put the value inside. Then F2 is square root of 7 square plus 4 square plus 3 square, and that is equal to square root of 74. Then R dot F2, as I said, is negative 81. I already mentioned that. So R dot F2 is negative 81. Then inverse cosine of negative 81 divided by the quantity square root of 497 times square root of 74. we obtain the angle theta R2 to be equal to, so it's your part now, the theta R2 is equal to 115.0 degrees. So that's it for this video. I hope that you were able to follow the explanations, the solutions, and the concepts and theories on vectors.